So we subtracted the 3 cosine. This goes away. 5 cosine x minus 3 cosine x is how many cosine x? 2 cosine x equal to root 3. Now I'm going to divide by 2. Divide by 2. So cosine x is what? Now I ask myself, at what angle on the unit circle was the cosine equal to root 3 over 2? Okay, so look. Yes. So I want the cosine, which is always the horizontal, to be root 3 over 2. Now remember, root 3 over 2 was the longer side of the triangle. Okay, that means this is the shorter, so it has to face the small angle, pi over 6. Okay, so it's pi over 6. Now, but that's not all. Where is cosine positive? Here and here. Okay? If I want my angle to be positive root 3 over 2, that means it could either be in the quadrant 1 or quadrant 4. So if it's pi over 6 here, what's the over 6 angle in the fourth quadrant? It's pi over 6. What is it here? 11 pi over 6, right? It's pi over 6, 5 pi over 6, right? 7 pi over 6, and then 11 pi over 6. So in this quadrant, it's 11 pi over 6. Yes. Okay? And to this we add plus 2n pi plus 2n pi. Okay? All right, let's do one more. Yeah.
Why did you only say that half of the circle?
Because we want the cosine, we have that the cosine is equal to positive root 3 over 2. Right. Cosine is positive in these two quadrants. Okay. So we look at the angle in those two quadrants. Okay. Wait, she was first. Go ahead.
I don't understand why you have to.
Because it's cyclical, right? The cosine, like this pi over 6 and 11 pi over 6 is only for one period. But if you draw the cosine, it keeps going forever until infinity. So pi over 6 is the same as pi over 6 plus 2 pi, plus another 2 pi, plus another 2 pi. Because if we keep adding 2 pi, we're going to go to the same angle. Yeah. Because that's what the equation told us, right? When we solved the equation, we got that cosine x turned into root 3 over 2. Right? That's defined by the equation itself. Now, there are going to be some examples where it's plus or minus, and you'll see the difference there. Okay? Well, let's do this one. 3, okay, so we're going to add 4. 3 tangent squared x is equal to 1. Tangent squared x is equal to 1 over 3 because I divided the 3. Okay? Now, what do I do to get the square to go away? Take a square root of both sides. So now I get that tangent of x is equal to plus or minus root 3 over 3. Okay? Now, where is tangent of x equal to root 3 over 3 on the unit circle? Well, we can check at the 30 or the pi over 6. Okay? What do we have? We have a 1 over 2 and a root 3 over 3. Tangent is opposite over adjacent. So yeah, that's the angle. Okay? So it's at pi over 6. All right? Now, hang on. So here I have that tangent of x is equal to positive root 3 over 3. Tangent of x is equal to negative root 3 over 3.
Why is that one?
Okay? Because this one we took a square root. Okay? Now, Because the other one didn't have a square root. This one does.
So
The other one wasn't squared.
So when you take the square root of both sides, it's always plus 1.
Okay, so,
Oh, I guess because it equals
okay, I have two people.
nothing.
Two people are coming to Revelations at the same time. You guys are coming to the right revelation. Okay. All right, so now tangent is equal to root 3 over 3 at the pi over 6. Now, where else, which other quadrant is tangent positive? In quadrant 3 here. What's the pi over 6 in that quadrant? It's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So in here, in that quadrant, it's 7 pi over 6. Okay.
Like, should we memorize all of these?
Well, you should already know all of these from last chapter, right? This is why we were doing last chapter. Okay. So 7 pi over 6. And then for the negative angles, right? The negative angles are here and here. Okay, so that's 5 pi over 6, 11 pi over 6. And then because they repeat, how often does tangent repeat? What's the period?
Pi.
Every pi. So for these we add plus n pi, not plus 2n pi. Okay? For the cosine and the sine, the period is 2n pi, so it repeats every 2 pi. But for the tangent, it repeats every pi. See how things are coming together? Okay.
So everything is 2 pi except for tan.
Right.
And so tangent is
Pi again. Okay. Here, we're going to solve not over the whole spectrum of the real numbers, just from 0 to 2 pi, over one period. That means we don't have to keep adding the 2 pi's, okay? That's all that changes. Okay, so what are we going to do here? We want to be able to solve this. So what you do is, when you have a sine and a cosine together, you can't separate them, and you have a sine off to the side here, bring everything to the same side, and then something magical will happen. So let's do that. Let's subtract negative 3 sine x, a negative root 3 sine x. So we get 2 sine x cosine x minus root 3 sine x equal to 0. Now, you see how I have a sine x here and a sine x there? I can factor that out. So I get 2 cosine x minus root 3 is equal to 0.
oh.
Okay. Now, you know how when we solve a quadratic equation by factoring, we get something like this, 2x minus 3, x plus 2 equals 0. And then what do? We set each one of them equal to 0, right? That's what we're going to do here. We're going to set each one of these equal to 0. So here I get sine x equal to 0. Well, that's already simplified. Here I get 2 cosine x minus root 3 equal to 0. Is that simplified? No, but we can simplify it. I add root 3. Two cosine x equals root 3. Divide by 2, divide by 2. Cosine of x is root 3 over 2. Now, I ask myself, where is sine of x equal to 0? Well, sine of what equals 0? Sine of 0 is 0, and sine of pi is 0, okay? So x here is 0 and pi, okay? And now here, where is cosine equal to root 3 over 2? Now, if I want the cosine, which is the horizontal side, to equal root 3 over 2, that means the vertical side is the small 1/2. That means it's facing a small angle of pi over 6. Okay? So it's pi over 6. Now, in what other quadrant is cosine positive other than 1?
No.
4. In the fourth quadrant, what's the equivalent of pi over 6? What's the over 6? It's 11 pi over 6. Okay? When you put it all in order, which is conventional to do, you get 0, pi over 6, pi, 11 pi over 6, and that's the answer. Now, I'll answer some of your questions for you. Do I take points off if you don't put it in the right order? No. Do I take points off if you have one of these missing? Yes. Do I take points off if you have an extra one? Yes. Okay? So always think of, if this was an equation of who in some hospital gets some specific medication, you don't want to miss anybody, and you don't want to give anybody that shouldn't be taking the medication. So you want to have the right ones up there, okay? Not that bad. And you know what? And I'll say this. This, people have been doing this since the Greeks, okay? So think about how many people before you have done this, and they've survived. We never hear in the history books about people dying because of, trig equations, right? Like that has never been cause of death, okay? And we'll never hear about it from here on. Okay, there is a vaccine. Don't worry about it. Okay, Dr. Mendelsohn has a vaccine. All right. This one, this is a first for this type of problem. We're going to factor again. Okay, so this is, I love this stuff because we did some of it, in the last lesson. So what we're going to do here is factor in quadratic form. So imagine if I had 2x squared plus x minus 1 is equal to 0. This is almost second nature to you guys now, because you just go in there and you say, oh, that's 2x and x. I have a 1 here, I have a 1 here, plus here, minus here, and that's it. Well, look, instead of 2x squared, I have 2 sine squared. Instead of x, I have sine. And for the minus 1, I still have a minus 1. So, we never factor that way. Quadratic always factors this way. Okay? So, what's happened really is that the x's have been replaced by sines. And that's all that happens. That is all. So instead of having 2x and x, I have 2 sine x and sine x. Okay? And I have a 1 and I have a 1. And now where to put the positive? The positive goes here and the negative here because 2 sine x minus 1 sine x must equal sine x. It's just like factoring a quadratic equation with x's. Okay? Now, just like before, I'm going to split it down the middle and I'm going to set each one individually equal to 0 and solve. So here I get 2 sine x minus 1 equal to 0, sine x plus 1 equal to 0, 2 sine x equal to 1, sine x is equal to 1/2, sine x is equal to minus 1. Okay? Now, on the unit circle, I want sine to equal 1/2. That means sine is the vertical side. The vertical side needs to be 1/2. If the vertical side is 1/2, that's the smaller side, what angle must it be facing? Pi over 6, the smaller one. So x is pi over 6. Now, where is sine of x positive? In this quadrant, and in quadrant number 2. What's the pi over 6 equivalent in the second quadrant? Can't be 2 pi over 6. It's 5 pi over 6.
But you also have a negative answer. So would you want
Where do I have a negative answer?
sin x equals negative?
Okay, I'm not there yet.
Oh.
Okay. Did you have a question, Hannah? Okay, now sine of x equal to negative 1. Remember, sine and cosine equal 1s or 0s at the quadrants. Okay? So where is, if the y-axis or the y-coordinate is negative 1, where is that? That's here. Okay? So that's 3 pi over 2. And that's it. I'll write it here. So that's the complete answer. All right? All right, so your homework for Monday is up to number 17. Okay, so that's like half of it. All right.